Hello and welcome to Chapter 13, Trigonometry. This is going to be 13.1. We're talking about the unit circle, sine, and cosine functions, not all in the same video because that would be really long. This video is going to be about the unit circle specifically. So before we fill out this lovely table, I want to show you what the unit circle is, and so we're going to go over here. So these two are exactly the same, so don't worry about that. Basically, the unit circle is a circle with a radius of 1, so 1 unit, so unit circle. And basically, we want to be able to say, okay, if I have an angle, let's say 60-degree angle, because that's what I have here. If I have a 60-degree angle, say I have just something, oops, I don't have my pen clicked, so that's not helpful. Say I have a stick, for lack of a better example. Say I have a stick that's sticking up at a 60-degree angle, and I need to know how high it is from the ground and how far away this is, right? I need to know. Let's do a better example than a stick. Say this is a ladder, right? And this is the wall of the house. You probably had an example like this in geometry class, right? This is a ladder. It's at a 60-degree angle from the ground. I want to know how far away it is from the house, and I want to know how high up the wall my ladder is going to go. So I want a quick way to be able to find this distance and this distance. That's my x and my y, right, on this unit circle, based on this angle here. And that's what this unit circle is for. For any angle, I can figure out the x distance and the y distance very quickly. And it's symmetrical based on corresponding angles in the different quadrants, and we'll talk about that. And then, so if I know what it is in on this circle, then I can scale it using whatever radius I have. So this is a radius of 1. So right now I'm saying if my ladder is 1 foot long, then it's going to be half a foot from the wall, because this is my x coordinate, right? It's going to be half a foot from the wall. But if my ladder is 60 feet long, well, then I can just scale it. So I can just do 60 times a half, and I know that it's 30 feet from the wall. So once I know this, once I know my unit circle, I can scale it with whatever radius I need. So if I need this to be 30, then that's what I multiply this by. If the ladder is 21 feet long, that's what I multiply this by. So I have these numbers in my head, and I can just multiply them very quickly with whatever this distance happens to be. In the unit circle, it's 1, which means that whatever it actually is, I just multiply that number, and I get my answer. So that's what the unit circle is useful for. So how do we get these numbers is the real question. So if this is a 60-degree angle, then this is a 60, 30, 90 triangle. Hopefully we remember that from geometry. This is a 60, 30, 90 triangle, which means that this side is 1. I said it was a half. It's not a half. It's 1. This side is the square root of 3. And this side is 2. No, this side is a half. Sorry, I'm confusing myself. This is, if this were 2, which we know that it's 1, right? But if this were 2, then this would be 1, and this would be the square root of 3. These are the numbers we use when we're learning the 30, 60, 90 triangle because they're nice, easy numbers. So this is a half. I'm just confusing myself, but this is a half. But if we remember from geometry, we talked about this being 1, 2, 1 and the square root of 3. And if you remember where that came from, it was an equilateral triangle. So if these are all 2, and then we cut it in half. So an equilateral triangle, every angle is 60 degrees. So if we cut this in half, then this would be 30. This is still 60, and now we have a 90-degree angle here. So if we cut it in half, then this side is now 1. So that's where this 1 comes from. That's where the 2 comes from. And then we use Pythagorean theorem to get the square root of 3. So just a quick refresher on where those numbers came from in the first place. But we're going to be using this triangle a lot. It's fine that these are not these numbers because these are the ratio that this triangle comes in. And what these numbers really are, this is the cosine of this angle, and this is the sine of this angle. So in the unit circle, we always have an angle, and x is always going to be the cosine of that angle, and y is always going to be the sine of that angle. So this is 60. So the cosine of 60, cosine, remember, show quick refresher on trig functions. Cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. So cosine is adjacent. So this is the angle we're looking at. So the adjacent side is this one. So cosine is adjacent over the hypotenuse. Remember, the hypotenuse is the leg that isn't included in the 90 degree. It doesn't touch the 90-degree angle. So this is the hypotenuse here. So adjacent over hypotenuse is 1 over 2, and that's where we get our half here. And then the sine of this angle is opposite over hypotenuse, so square root of 3 over 2, which is how we get this number right here. So these are just what we use to get these ratios. These are the actual lengths of these in our unit circle, which can kind of make sense. If this is 1, right, it makes sense that this comes down at a half. Hopefully that makes sense. So let's do another example really quick to try to get the hang of this. So let's do the 45-degree angle. So the 45-degree angle is a different triangle. Remember our 45, 45, 90 triangle? So this is a 90-degree angle. This is 45 degrees. This is 45 degrees. This is 1. This is 1. And this is the square root of 2. So the cosine, so we're going to do x, so we're going to do cosine first. Cosine of this angle is the adjacent over the hypotenuse, so 1 over the square root of 2. Sorry that I'm running into this and it's hard to see, but 1 over the square root of 2 is clearly not what's written here, so I want to talk about that for a second, which is why I wrote it down here, but I'm going to switch it to red so we can actually see it. Hopefully. That's not good. I'll write it over here. 1 over square root of 2. So there's this thing we have with square roots, we don't like to have them in the denominator. And we've talked about this before, but I want to talk about it again. We don't like having square roots in the denominator. So in order to get rid of the square root in the denominator, we multiply top and bottom by that square root. Hopefully we remember doing this. So we're multiplying by square root of 2 over square root of 2, which is 1, so we're allowed to do that. So on top, we just get square root of 2. And on the bottom, square root of 2 times the square root of 2 is just 2, right? Because then I have the square root of 2 squared, and the squared and the square root cancel each other out. So this is just 2. So you'll always see this written, you'll always see 1 over root 2 written as square root of 2 over 2, because we want to rationalize that denominator. So this is going to be the square root of 2 over 2. And it's going to be the same for sine. Sine of 45 degrees is opposite over hypotenuse. So 1 over the square root of 2, which again is square root of 2 over 2. And that's the main one that we have with this, because we're only really using 30, 45, 60, and 90 degree angles. So these are the numbers that we're going to be using. 0, 1, 1/2, square root of 3 over 2, and square root of 2 over 2 are the only numbers we're going to be using. And we're going to go through finding all of these angles here in a second. This video is going to be really long, sorry. But before we do that, I want to talk about the angles that are like 90 or 0 or 180. So if we have a 90 degree angle, right? This is a 90 degree angle. We don't really have a triangle here. So, but if we think about it, we've said that the cosine is x and the sine is y. So if the cosine is x, well, x right here is 0. That's very clear, like, right? X is 0. I'm not going any direction, right or left. So x is 0, and this is a unit circle. So the radius is always 1. So sine here has to be, or so y here has to be 1. So the sine of 90 degrees is 1, and the cosine of 90 degrees is 0. And if you put it in a calculator, that's what you would get. But we can see that on the unit circle, which makes it really nice. Same thing with any of these. So if I'm at 180 degrees, I can see I'm left 1, so I'm at -1 in the x direction, and I'm at 0 in the y direction. So the cosine of 180 is -1, but the sine of 180 is 0. So that's one nice thing about the unit circle, is it really helps you figure out what your sines and cosines are very quickly. I can very quickly think, if I have this circle in my head, I can very quickly think, okay, what is the sine of 150? And I can just say, oh, that's 1/2, because I have this picture in my head. Well, yeah. But that takes a lot of memorizing to get to that point. It's actually easier to do with radians than it is to do with degrees. So I want to talk about radians here for a second. So radians are just another way of measuring an angle. Basically, pi radians is the same thing as 180 degrees. So that's sort of the definition that we use. Pi radians is the same as 180 degrees. So if I'm trying to switch between radians and degrees, I'm going to use that fact. so let's do an example really quick here of that. Sorry if this video seems a little bit scattered. I'm trying to fit everything in, and you can let me know if you have any questions, anything that I need to clarify afterward. Anyway, so say I have degrees, like I have 150 degrees, and I want to know what that is in radians. I can multiply by pi over 180 because pi degrees is the same thing as, pi radians is the same thing as 180 degrees. So if I multiply by pi over 180, I'm not changing anything. I'm just switching between degrees and radians. You can think of it as a unit conversion. In fact, it is a unit conversion, right? I have degrees here, and radians here. So my degrees cancel, and I end up with just radians. So I'm going to do what is 15 over 180. Well, that's 5 over 6. So 150, over 180 is 5 over 6. So this is 5 pi over 6 radians. So I'm multiplying by pi over 180, and that gives me my radians. So that's what this is here. We have degrees on the inside and radians on the outside. And I will talk a little bit more at the end when I'm talking about patterns. We'll talk about why radians are actually easier to use when you're trying to keep this circle in your head so that you can access it easily. And we'll talk about some other patterns throughout the unit circle. I don't expect you to know all of this all at once, but getting it in your head will be really useful. And then next year in pre-calculus, those of you who are taking that, we will be memorizing this fully, so we won't have it in front of us during tests and stuff like that. We'll be making sure that this is in our heads. So I want to get you guys started on that now. All right. Quick note, if I want to go the other direction, so say I had 5 pi over 6 radians and I wanted to know what the degrees were, then I just multiply it by 180 over pi, right? Because now this is radians and this is radians, and I want degrees, so radians cancels and I end up with degrees. And if I did that math, right, the pi's would cancel. And if I did 5 times 180 divided by 6, I would get 150 degrees. So if you want to go from degrees to radians, you do it this way. Radians to degrees, you do it this way. Yeah. So for now, though, let's go ahead and fill out this table so that we can talk about some patterns. It's actually some really interesting patterns that are going to make this a lot easier. So first of all, we're going to go from degrees to radians, and then we're going to find x. Remember, that's cosine, and we're going to find y, which is sine. So, I'm just going to draw a very rough sketch of the unit circle over here. So at 0 degrees or 0 radians, we're here, right? We're on the positive x-axis. So x is going to be 1. So cosine of 0 is 1. Sine of 0 is 0. Y is 0. Okay? Then at 30 degrees for radians, remember it's times pi and divide by 180. So 30 degrees is going to be, my brain just completely stopped working. I'm just going to go back and look at it. It's pi over 6. I knew that. but again, my brain just decided not to think. So pi over 6. This is pi over 6. So again, excuse my handwriting. So if you did 3 divided by, not 3 divided by 18, 18 divided by 3, right, is 6. So that's where that comes from. Or, like I said, multiplying by pi over 180. And then, I'm going to draw the triangle to find the cosine and sine. So again, this is going to be a 30, 60, 90 triangle. So this, I'm just going to put, here's our 30. I'm going to make it bigger so it's not completely sloppy. So this is our 30-degree angle. This is our 60-degree angle. Here's our 90-degree angle. So it's 1, 2, square root of 3. All right, so our 30-degree angle is here. So cosine of 30 is going to be square root of 3 over 2. Sine of 30 is going to be 1 over 2. And then 45, again, we have that nice 45, 45, 90 triangle. So sine and cosine are always the same here. It's always 1 over the square root of 2, which, as we discussed earlier, is square root of 2 over 2. So this is going to be square root of 2 over 2 for sine or cosine. And I forgot to do the radians, so in a second I'll do that, but I want to write this first. So then in radians, 45 degrees is going to be pi over 4. Again, if you did that conversion times, so 45 times pi divided by 180 is going to give you pi over 4. But for me, I just remember that they both have a 4 in them, and then I just have it memorized, so I don't actually do that math ever. So the one with the 4 goes with 45 degrees. And then for 60 in radians, that's going to be pi over 3. So how I remember these, which clearly was failing me earlier because I couldn't remember this one, 30 degrees goes with pi over 6, and 60 degrees go with pi over 3. So the one with the 3 goes with the one with the 6, and the one with the 6 goes with the one with the 3. So they're switched. Hopefully that helps and doesn't just make you more confused that they're switched. Which makes sense because if you have a smaller number on the bottom, that's a bigger number, right? Bigger number on the bottom is a smaller number. But yeah, that's how I remember that it's 3 and 6, is that it's just switched. Hopefully that helps and isn't just terribly confusing. So that's, so cosine of pi over 3 is going to be 1 over 2. And sine of pi over 3 is going to be square root of 3 over 2. And notice that those are the same numbers as these. They're just swapped, which always happens with the 30 and 60 degree angles. It's the same numbers, but swapped. So the cosine of 30 equals the sine of 60, and the sine of 30 equals the cosine of 60. They're switched. Okay, so 90 is pi over 2, which makes sense because 90 is half of 180. So pi over 2. And let's look back at our little circle here. So we're right here at 90 degrees. So cosine or x is going to be 0 and sine is going to be 1. Y, right? Y is 1. And then from here, we're going to go on in the same pattern, 30, 45, 60, 90. We're going to go from 90. So we're adding to 90, we're going to add 30. So 90 plus 30 is 120. So that's the next one. And that's going to correspond with with 60. Because if we look at the unit circle, I'll make it a little, well, I'll just go to the other page. If we look at this, right, the angle that we're measuring is always from the x-axis. So it's this angle, and then it's this angle. So 120 is actually the same angle as 60. 120 is the same angle as 60. So the numbers are going to be the same, but we'll just have a negative because we're in the negative x side of things. So all of the x terms are going to be negative because we're over here. But other than that, it's going to be the same as the 60. So don't be confused and think this is the same as the 30 because we added 30 to 90, right? But because we measure the angle from the x-axis, so this is a 60-degree angle here. This is a 120-degree angle, but this is a 60-degree angle. So this distance and this distance that we're finding are measured off of a 60-degree angle. So 120 corresponds with a 60-degree angle from the x-axis. So these numbers that I'm going to put in here are going to be the same as these, except for x is going to be negative because now we're over here on the negative x side of things. So this is going to be negative 1/2 and negative square root of 3/2. Nope. Y is still positive. Y is still positive. So this is actually positive square root of 3/2. So negative 1/2, but positive square root of 3/2 because y is positive over here. And then in radians, this is going to be 2 pi over 3. It's going to be 2 pi over 3. And again, you could do the math. You could look over here, but it is going to be 2 pi over 3. And I'm going to talk about those patterns later, maybe in a different video, because this video is going to be horrendously long. We'll see what happens. Okay, so continuing on, 90 plus 45 is 135. You could just add 15 to 120 because 30 plus 15 is 45. So you could add 15 here, or you could just add 45 to 90. You got 135 as your next angle. This is going to be 3 pi over 4. 3 pi over 4. Notice the one that corresponded with 60 had a 3 in the denominator. 60 has a 3 in the denominator in radians. And the one that corresponds with 45 has a 4 in the denominator. 45 has a 4 in the denominator in radians. Okay, so this corresponds with 45, so it's going to be the same numbers, but again, x is going to be negative. And square root of 2/2, but the y is positive. And then for 60, so either 90 plus 60, or you could do 135 plus 15 again. That would also work. Either way, it's 150. And this is going to correspond with a 30-degree angle. So if you look at that unit circle we've been looking at, this corresponds with a 30-degree angle. And it's going to be 5 pi over 6. 5 pi over 6 in radians. Notice that it corresponds with a 30-degree angle, pi over 6. Denominator is 6. So that, for me, really helps me remember what angle it's corresponding with, is that the denominators match in radians. So this is, for me, that's the easiest way to remember, oh, this is a 30-degree angle because the denominators in radians match. Like the 150 and 30 have nothing in common. There's nothing about 150 that tells me, oh, that's a 30-degree angle, or that the reference angle is 30 degrees. That's what we call this, by the way, this angle. So this is the actual angle, right, 120. This is called the reference angle because it's the angle that corresponds with its quadrant 1 angle. Yeah. Yeah, so again, these are going to be the same numbers as 30 degrees, but x is going to be negative. So negative root 3 over 2, 1/2. All right, then we have 180. 180. So this corresponds with our 90-degree angle, or it's over here on our unit circle. So that's going to be pi. Remember, that was the definition of radians, is that pi is 180 degrees. So this is just going to be pi. And then over here, we're at x is negative 1. So we're just going to read that off of the circle. So we're at x is negative 1. And y is 0. So for these, for the 0, 90, 180, 270, those angles, we just read them straight off of the circle. That's the easiest way to remember, is you just picture that circle in your head, say, okay, that is on the negative x-axis, so I know that x is negative 1 and y is 0. Easiest way to remember these. Again, I'm not expecting you to have these memorized right away, but this is a good time to get started on that. All right, so then the next one is going to be our next, we're just going to add 30 to 180. And this is going to correspond with a 30-degree angle. So we're adding 30, so we get 210. 210. That's going to be 7 pi over 6. So notice again, the denominator is the same as all of the ones before it that had to do with a 30-degree angle. Just want to show you that's here. So this is our 30-degree reference angle right here. So this is what is 30 degrees. So that corresponds to this being 30 degrees. But now we're just in this quadrant where everything is negative, right? X is negative and y is negative. So this is a 30-degree angle, but with everything negative. So negative root 3 over 2, negative 1/2. And then, so just like this one, except for now everything is negative. So then the next one is going to be our 45-degree angle. So 180 plus 45, or 210 plus 15. So 225. And so that is going to be 5 pi over 4. 5 pi over 4. And then again, it's a 45-degree angle. See the over 4, over 4, over 4. So it's going to be that the square root of 2 over 2, but they're all going to be negative. All right, so let's do our 60-degree angle. So I'm going to add 60 to 180, so that's 240. Yeah, yep. I work in radians more than I work in degrees, so sometimes I forget what I'm doing in degrees. All right, so this is our 60-degree angle. So we're going to be at 4 pi over 3. So notice all of the 60-degree angles have that 3 in the denominator. And so this is going to be just like 60, except for everything's going to be negative. So we're going to have negative 1/2 and negative square root of 3 over 2. And then the next angle is 270. That's this one right here. So this, again, we're just going to read off of the circle. So this is going to be x is 0 and y is negative 1. Oh, and by the way, this is 3 pi. 3 pi over 2. So 90 was pi over 2. This one is 3 pi over 2. 90 was here. 270 is here. So pi over 2, 3 pi over 2. Okay. And then last quadrant. So now we're over here. So now x is back to being positive, but y is still negative. So x is positive, y is negative. Our next one is going to be our 60-degree angle, because it's always measured from the x-axis. So this is going to be our 60-degree angle. So looking at this, we are here at 300. This is going to be a 60-degree angle. That's our reference angle, is 60 degrees. So 300 is our actual angle. Our reference angle is 60 degrees. So this is going to match our 60-degree angle. So again, we're at 300. That's 11 pi over 6. And that's going to be, again, that's a 60. Nope, not 11 pi over 6. This is a 60-degree angle, which means we are at 5 pi over 3. So all of the 60-degree angles over 3, over 3, over 3, over 3. 60-degree angles, always over 3 in radians. So we have positive 1/2, negative square root of 3 over 2. Because now we are over here where x is positive and y is negative. All right, so next one, 315. It's our 45-degree angle. So 7 pi over 4. And so we're at 45 degrees. So 45 degrees, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Always over 4 when it's 45 degrees. So this is going to be square root of 2 over 2. Negative square root of 2 over 2. And then here we have 330. So this is our 30-degree angle. It's our 30-degree angle. So this is 11 pi over 6. And so all of the 30-degree angles, pi over 6, over 6, over 6, over 6. And so this is going to be square root of 3 over 2, negative 1/2. All right. And then the last one is 360. That's back over here, so that's exactly 0, right? In radians, that would be 2 pi. 360 is 2 pi. This is the exact same thing as 0. Generally, we don't use 360 because we don't like to define one point in two different ways. So we're going to use all of these and not use 360. But I wanted to write this just to remind us that we can call this point 360. And then we could keep adding to that and go around the circle again. So there's actually an infinite number of angles that we could use to define each one of these points. Because if I take any one of these points and I add 360, right, that's a whole revolution around the circle. If I add 360 to any one of these, I would end up at exactly the same point. So there's an infinite number of ways to name each of these points, but I'm just going to use these. And generally people just use these. Every once in a while you use 360, but usually we just know that it's the same thing as 0 and we don't use it because we prefer to use 0. Because it's kind of an either or thing. You can use 0 or you can use 360, and we just use 0 because 0 is nice and easy. So a lot of times you'll see something like this. Remember that 2 pi is the same thing as 360. So this is saying that theta is between 0 and 2 pi, not including 2 pi. Notice there's an or equal to here, but not here. So we're saying we're including 0, we're not including 2 pi. You'll see this a lot, especially when we get into pre-calculus, when we get into the trig there. This is used a lot just to say make sure and remember that all of your radians are in this zone and not including this one because we don't want to define this point twice, right? We want to use 0 or 360, not both, so we write it this way. Okay, this video is already ridiculously long, so I'm going to stop here. And then in the next video, I'm going to talk about some patterns that we can use to help us remember the things on our unit circle. So that's the next video. Hope this is not too terribly confusing. If you have questions, please ask. And I'm willing to make more videos if you want something explained. All right. That's all I have for you for now. Make sure you watch the next video because it's going to have some helpful hints and tricks on remembering the unit circle. I will see you there.